Hello everyone, this is Sheikh Siraj. I am from EC department. My subject is probability theory and static process. Today my topic is exponential random variable density function. Here my roll number is there. So now today I am explaining about exponential random variable density function. The exponential probability distribution is useful in describe the time it takes to complete a task. The potential random variable can be used to describe time between vehicle arrivals at a toll booth, time required to complete a questionnaire, distance between major defects in a highway, the time between goals scored in a World Cup score match. Here we know that potential probability distribution. Here there are given some examples like World Cup map and a vehicle. These all are density function. What is mean by density function? Here is their density function. F of x is equals to 1 by mu e power x of by mu for x greater than 0, mu greater than 0, where mu is equals to mean is mean median more like e is equals to 2.71828. E is equals to here value is there, e is equals to 2.71828. Cumulative probabilities here p of x less than x naught is equals to 1 minus e power minus x naught by mu, where x naught some specific value of x. Here x naught is equals to some specific value of x. Example, A1 is full service pump. Example, the time between arrivals of cars at A1 full service gas pump follows an exponential probability distribution with a mean time between arrivals 3 minutes. A1 would be like to know the probability that the time between two successive arrivals will be 2 minutes or less. So here example is that A1 is full service pump. So the time between arrivals of cars means two cars are there or any one car. With a mean time between arrivals 3 minutes means it is arrivals in 3 minutes. A1 would like to know the probability that the time. So A1 is know that time. Here solution is there. How to we solve that? P of x less than 2 is equals to 1 minus 2.71828 minus 2 by 3 is equals to 1 minus 1 point, yeah, 0.134 is equals to 0.4866. Example, if jobs arrive every 15 seconds, on average lambda is equal to 4 per minute, what is the probability of waiting less than or equal to 30 seconds in 5 minutes? So here question is that if jobs arrive every 15 seconds, on average lambda is equals to 4 per minute, what is the probability of waiting less than or equal to 30 seconds? 5 minutes. So now we are finding that what is the probability. P of t means time less than 5. So here integration is doing e power minus, we know that everything of this problem. First of all, we want to know that what is the formula of time taken by value. Characteristics. What is characteristics? Here we know that the mean and standard deviation of exponential distribution are equal. So mean is standard derivation of exponential distribution are equal. This is equal. So distribution is exact, extremely skewed, and there does not exist any mode. Here we know that the distribution is extremely skewed and there does not exist any mode. This is two types of characteristics. Graph of the exponential distribution with mu is equals to 1. So here graph is there. How we will this do means, first of all we are taking 0 1 2 3 4 5 on x-axis, x-axis y-axis not there, but we are taking points 0, 0.0, 0, 0.2, 0, 0.4, 0, 0.6, 0, 0.8, 1.0. This all are. So now we are graphing that in this place 0 is 1.0, in place of 1 0.8, in place of 2 0.2, in place of 3 0 0.00, some 2 or 1 in its sum, in the place of 4 that's also 0.001, in case 0.05. Oh, in this ppt we know about the potential random variable can be used to describe time between vehicle arrives at a toll booth, time required to complete a questionnaire, distance between major defects in highway, the time between goals scored in a World Cup score match. Means here we know that the potential probability distribution is useful in describing the time it is takes to complete a task. So we are know how to time travel and what is the time management. No, exponential random variable can be used to describe. How we know about exponential random variable density function? Here we are know about exponential random variable, and here we know that how to density function is finding, how to density function is using in this type of solutions, like f of x is equals to 1 by mu e power f u e power minus x by u for this is the type of density function. So in this function we are knowing that how to solve the function of the probability and density of function of the probability density finding. In this case we are solving these problems. Cumulative probabilities means it is also one type of solving problems in probabilities. Cumulative, yes. And example, you know that I am already tell that, like this is a one type of example. A1 is full service pump, means one pump is there, one tire is there, one car is there. So the car is arrives say on the time. So the distance between pump and the car, the time is how much taking, that is only 2 minutes or less. This is the probability. How do we find the time in this solution? We know that every, yes, this is also if jobs. Other example is there. If jobs arise every 50 seconds, on average lambda is equals to 4 per minute. What is the probability of waiting less than or equal to 30 seconds? 5 minutes. So here also we know about in solution characteristics, the mean and standard describe derivation of exponential distribution are equal. The mean and standard derivation of exponential distribution are equal. The distribution is extremely curved and there does not exist any more. So graph, thank you for watching. So I think we you all are know about how to solve density function and exponential random variable of probability time at that. So thank you one and all.